this CPU board done yet?
Well,
I've been on the phone with the division manager. He's all over me. He's hot. This board is holding up the entire project. You said you'd have it done this week. What's the story?
We're really pushing the clock rate on this board, and I'm finding high-frequency glitches that I've never had to deal with before. We're going to have to build at least one more prototype. That'll take another 2 weeks.
It's not acceptable, John. You've got to find a better way. Think about it tonight. I want to see your ideas on my desk first thing in the morning.
What am I gonna do? Wait a minute. What was that thing I was reading about the other day? Oh yeah, here it is. I better find out more about this.
Hello, I'm Mary Brown, and I'm the Product Marketing Manager for BoardScope. Lab environment is a second home for most high-frequency design engineers. Creating and implementing the design are only the first two steps in a process which can be very lengthy, costly, and time-consuming. The vital step of design verification through iterative prototyping is commonplace to manufacture a high-frequency PCB. An article in PCB Magazine's June 1989 edition quoted a price of $65,000 for a single prototype design iteration for a surface mount 8-layer PCB. Furthermore, this does not include the cost to design and lay out the board the first time, nor does it include the loss in revenue due to the delay in reaching the market. According to this chart, a 6-month slip in time to market can cost a company 33% of after-tax profit over a 5-year product life. How many companies can afford this? Since more and more designs are involving high-speed components, companies are having to deal with the delays and cost of high-frequency design. Some design engineers, in an attempt to alleviate layout-induced problems, follow very conservative design rules. Rules such as strict adherence to no-stub routing, as well as the routing of critical signals on dedicated trace layers, are two examples. Both of these result in a board that takes longer to route while consuming more real estate. In either case, the design engineer has to interact with the PCB designer extensively throughout the layout and routing phases. Whatever the method, the bottom line is always the same. The design cycle is longer, and still there is no guarantee of signal integrity without building costly prototypes. Therefore, in order to eliminate some of these costs and delays associated with high-speed design, our goal then is to reduce these prototype cycles. Dazix introduced BoardScope, a new transmission line simulator based on proprietary algorithms to address these design issues, while the board still exists only in software. BoardScope evaluates the effects of combining logical devices with the physical attributes of the printed circuit board. It predicts transmission line effects such as ringing, reflections, and impedance mismatches.
You know, this sounds really great, but I'm already behind schedule. I can't afford to take my engineers and have them spend a couple months learning how to use this.
Well, that's the beauty of this product. Your engineers are already used to working with oscilloscopes today, and BoardScope's graphical interface is designed with that in mind. When using BoardScope's virtual oscilloscope window, the engineer is emulating the real-time prototype environment with one very important difference. The board under test is still in software, the ideal stage for error detection and correction. For example, within the virtual oscilloscope window, the engineer can view time-domain waveforms for every electrical point of interest within the suspect net.
That's fine, but how do I find these suspect nets? Do I have to probe the entire board?
No. BoardScope can be used to audit the entire board or selected signals against user-definable criteria. BoardScope's powerful rule checkers allow the user to customize the simulator to better suit his or her design environment.
What design rules does BoardScope check for?
Within the waveform rule check, it checks for overshoot, undershoot, and time delays. One example within the topology rule check is maximum trace length based on fan-out.
What happens when I do find a trace length violation? Do I have to start the whole design over again?
No. Due to the tight coupling between BoardScope and Dazix PCB environment, problem nets can be corrected within the PC editor or within BoardScope's own transmission line editor, TranEd. TranEd has a unique ability to isolate a single net from a completed PC board. This allows the designer to experiment with changes to the geometry of this net without having to modify the entire board layout. Now, a designer can tweak the layout to check for improved signal integrity before extensive work is done to relay out the entire board. Prior to BoardScope, this kind of design analysis was not feasible due to cost.
How does BoardScope know what signal characteristics are produced by each component?
No simulator is complete without accurate component models. BoardScope's models incorporate driver load characteristics, package modeling, as well as timing information.
Sounds great. How do I get one? John, I don't want to repeat the last project. What's the status of this board? Are we on schedule?
Don't worry, since we purchased BoardScope, I'm sure we'll beat our schedule.
Really? Why do you think that?
Well, because BoardScope has already uncovered several problems with reflections as well as a false clock on the 50 megahertz board. And normally I wouldn't have found that till the first prototype. That alone saved at least 2 weeks in debugging.
That's great. How does this thing work?
Well, I've already used BoardScope to analyze my completed layout. During the analysis, waveform and topology rule checkers flag potential problem nets. I already have the layout designer correcting some trace length violations I discovered, but what I'm really concerned about is adhering to the noise margins for the board. The BoardScope rule checkers contain defaults based on the manufacturer's data, but I've supplied my own guidelines for this design. I was just getting ready to look at each flag net individually when you walked in. One net that could be causing my problem is my driver net. See, it's this one right here. Let's select it and tell BoardScope we want to simulate it. After I invoke BoardScope, it will automatically prompt me for more information. In this simulation form, I can enter my input pulse and set my scope emulation parameters.
You mean you can even emulate oscilloscope parameters?
Sure, I just specify the bandwidth and the roll-off of our lab scope. This allows me to see comparable waveforms in BoardScope as I would see during the prototype testing in the lab.
That's neat. Let's use it to look at that driver signal.
Notice that BoardScope produces a waveform for every electrical point of interest on the net. See, here's the driver, loads, and the terminator. The node names are color-coded with a corresponding waveform. If I want to, I can eliminate some of the waveforms from view so I can just concentrate on the critical nodes. See here? I've isolated one node on my driver net that needs some tweaking.
So what?
Well, that's one of the neatest things about this tool. I can use the TranEd window to experiment with some layout changes on this node to see how it affects the signal. TranEd lets me change the parameters of elements within the net, such as the trace length of this stub. Let's decrease it to 1 inch. This may be causing my problem since it's so close to the driver. Good, looks like that'll do it. I could also see what happens if I move the stub further down on this net by changing the trace length.
What's happening to the rest of the layout while you're working on this node?
Well, that's what's great about this. Whatever adjustment I make doesn't affect my design database until I've finished all of my testing. So I can verify any modification prior to telling the layout designer what to change on the board.
Well, I'm impressed. I'm going to see that the rest of the people in the department start using BoardScope right away. Maybe we can finally earn one of those famous bonuses we've been hearing about.